All right, so this is team ranking 2. This is a summary of what's called the Massey Method. So this is named after Kenneth Massey, who developed this method actually when he was an undergraduate, the method we've been looking at. And so what I'll do is I'll give the sort of a recap of what we did, but then I'll talk about the actual method in the sense that like we can just cut to the final matrix really, really quickly. So sort of we could say that the long approach would be as follows, is we write down the system of equations that corresponded to the games they played. So turn into a matrix equation. Which I had called A R bar equals B. This is the one that doesn't have a solution, probably. And then we do the least squares start. Not all the way, but we start it. And we get this. Now, this is the one that had infinitely many solutions. So then what we do is we replace the final row of ATA by 1s and the final entry in ATB by 0, and then solve. And that final solution is just directly with the inverse. Now, the quick approach, of course, the shortcut is as follows, is that this final matrix, right, the final matrix equation that we solve, we'll call this, say, M R hat equals Q, is as follows, right? So M is T by T, where T is a number of teams. So the final row of M's is all 1s. The final entry of Q is 0. And otherwise in M, the little m sub I is the total number of games team I played, and Mij, when they're different, this is the number of games, also this is the negative number of games that teams I and J played. Then we just solve. So let me do this. Let me clear the screen. I'll give an example, and we'll fill this in directly. We'll go straight to the shortcut. Now, the one note I want to make with the shortcut is, I'm going to have to erase it, but I'll make this note, is, oh, actually, there's one last thing I need to say, is that we need to fill in the rest of the Q's. So otherwise, not quite yet, otherwise in Q, Qi is the total number of points team I won. And then we solve. So the one caution I want to give you here is to, when you're calculating these, just be careful. It's very, very easy, especially when you're doing this by hand, or even if you're adding them up on a calculator, for example. It's really, really easy to make a mistake when you do these. So, I'll write down an example and we'll go through it really, really carefully so that we see. So, to example. So, we'll have 5 teams. And so we'll have a list of games. And so T1 versus Team 2, and we'll say win by 3. Team 1 versus Team 3, we'll say tie. I'm pulling this straight out of the book, so it's easy to reference. Team 1 and Team 4 win by -2. That's a loss. That's okay. Team 2, Team 3 win by 1. Team 2, Team 3 win by 2. So we want a bunch of games to sort of make this a little bit more realistic. Team 2, Team 4 win by -3, or a loss if you like. Team 2 versus Team 5 win by -5, another loss. Team 3, Team 4 tie. Team 3 again, Team 4 but loses. Team 3 v Team 5 tie. 2 more. Team 4 versus Team 5 win by 4. And last but not least, Team 4 versus Team 5, and now they're going to win by, they actually have a loss. So here's the matrix equation. So there are 5 teams. So this matrix, which I called M, is 5 by 5. We have a ranking vector. We have an entry of a vector with 5 entries. So without doing any thinking at all, we can fill in the 1, 1, 1, 1, 1, and the 0. Then we need to start thinking. So what we'll do is, I think it's easier, there are a variety of ways you could do this, but I think it's easier for me to fill in the diagonal entries first, because those are just the total number of games. So for example, Team 1 played 3 games. So I put in a 3 in the upper left entry. Whereas say Team 2 played 1, 2, 3, 4, 5 games. So in the 2-2 entry, I'll have 5, right? And so on and so forth. We can calculate the final ones. Teams 3 and 4 played 6 games each, and you can calculate those out. Now notice that the number of games that Team 5 played isn't stored anywhere, right? It got replaced by that 1, but it doesn't matter because we can calculate that intuitively. Like, we don't need to calculate it, but the information isn't lost because we know it from all the other teams. So now the rest of the matrix is symmetric. That makes things pretty nice. I only need to calculate sort of maybe the upper right hand bit, right? So look at, say, Team 1 and Team 2. Team 1 and Team 2 played a single game. So what that means is I put a -1 right here. Right? So it's the negative of that number. So that's that -1 that went in. It's also going to make it a -1 here because of the symmetry. So then we go through the same thing. We say, well, Team 1 and Team 3 played 1 game. So I put a -1 and a -1. Team 1 and Team 4 played 1 game. Team 1 and Team 5 never played, interestingly. So then we go to Team 2. Team 2 and Team 1 we've taken care of. Team 2 and itself we've taken care of. Team 2 and Team 3, they played 2 games. So I get a -2 here and here. Team 2 and Team 4 played 1 game. So I get a -1, -1. And Team 2 and Team 5 played 1 game. So -1. I don't make that symmetric. Right? So just to be clear, the matrix is symmetric except for the blues. The blues are sort of the things that have overwritten it. So then we look at Team 3 and Team 4. Team 3 and Team 4 played 2 games, so a -2 and a -2. And Team 3 and Team 5 played 1 game, so -1. And Team 4 and Team 5 played 2 games, so -2. So again, just so we're remembering, before we fill in Q, is MII is the number of games Team I, and MIJ is the negative number of games Team I versus J. So then we go over to the right. And this is a bit where it's easy to make the mistakes, right? So we want to know overall how many points did Team 1 get, right? So Team 1, if we look at all of Team 1's games, they earned a single point overall. So that gets a 1 in here. Now, this can get a bit tricky, for example, when we want to look at the number of points that Team 2 earned, right? So let's run through that. Just looking at Team 2. So Team 2 lost here. They won here. They won here. They lost here. They lost here. That should be a -5, by the way. Bad at math. So those are all the Team 2 games and the sums that and the points that Team 2 earned. So if we add those up, we have -5 and the -3 and the 3 cancel. So we have a total of 8. So Team 2 overall lost 8 points, rather -8. So that's that value right here. Right? So just so we're clear, this over here, QI, is the total points earned by Team I. So again, we can go down the line. We can say that Team 3 earned -4 overall, and Team 4 earned 7. Right? And again, the Team 4 earning 7, if we want to, we can run through that real quick. Team 4 played here 1 + 2. This is Team 4 we're doing right here. Team 4 had +3. Team 4 had 0. Team 4 had +1. Team 4 had +4 and -3. We add those up, we get 7. So now that we've got this matrix equation, we just solve it. This is what we get. I'll give an approximation because it's a little more useful in the sense that we can actually compare things. This is -0.002899. This is -1.438. -0.6261. And 1.055 and 1.012. So we might say something, for example, if we wanted to put them in order, just to, without actually a numerical sort of an analysis of the whole thing, we'd say that, say, Team 4 is best because it's got the highest number. Team 5 is next. They're pretty close though. Team 1 is next. That's a pretty big jump in here, right? Because Team 5 has 1.012 and Team 1 has a negative number, so it's a pretty big jump down there. Then we go to Team 3. That's also a pretty big jump. I don't mean anything specific by the double greater than, other than I'm just sort of pointing out that it's a bigger jump. And Team 3 is still pretty far over Team 2. Team 2 sort of did really, really badly overall. So, a couple of final commentaries. So one thing is that the ranking is relative, right? So one thing to keep in mind is that these values in and of themselves don't mean anything, right? So to say, for example, that Team 4 has a ranking of 1.055 it's not anything absolute, right? So the scores have no absolute meaning, but they have relative meaning. So, for example, in a game like this, right? Team 1 never played Team 5. Right, but for example, if I look at R1 minus R5, right, in our hat version, if you like, right, what we get here is 1.104, approximately, 0.99, right? That comes from taking R1 or rather, just be careful, sorry, this should be negative. So this is from taking this value minus this value. So we might expect team 5 to win by 1.104099, or team 5 or team 1 to lose, right? Now, I'm not saying there's any kind of prediction thing, but it gives us a method of sort of understanding how they might be related to one another, even if they never played a game together. Right? So this can be interesting. This can be useful. So a couple of other comments I want to make. Let me clear a little bit of the screen off the left-hand side so we can make these comments. So a couple bullet points that are obvious because we've dealt with it, but just to sort of summarize, ties are managed. All right, so in the sense that like it's not a problem. Multiple games are managed. Because you can list them more than once. Right, now there's a comment here about weighted sets of games or weighting games. So for example, just sort of a real world situation, it's very often common that when a team plays at home, they sort of have an advantage, right? There's a home field advantage. So that can be factored in using historical data by weighting those scores appropriately. So for example, you might say like, well, if a team wins at home by 5 points, maybe we should only count it as 4. Right? So we can weight games by adjusting point values as necessary. So this will be more explored in the group work and in the project. But a final note, this will also be explored, is that if you have a situation where we have disconnected sets of games, then the Massey method will fail to work because there's no interaction between groups of games. So in disconnected sets of games, this is something to watch out for and make decisions about. So just for a pseudo example, right, you can imagine, say, 4 teams. Say team 1 beats team 2 by, say, 3 points, and team 3 beats team 4 by, say, 4 points. So in a situation like this, right, like there's no comparison between the first group and the second group. And so even if you do the Massey method, this method, it will fail to work. Like you will not get a solution. Right? So the solution demands a certain amount of interactivity between the teams. Right? So there's no connection here. Now, in some sense, that's okay, because you know, if you have no connection between these groups of teams, it's not even reasonable to ask for a ranking between them, right? Like you wouldn't have a situation like this and say, what about teams 1 and 4, right? Without some sort of connection between them, it's impossible to know. So this is, in some sense, this is not a big deal, but it's something to keep in mind as sort of we're working through an example, and like what can happen if you have groups of teams and then all of a sudden they play together, then how does that impact their overall connectivity and so on. So let me close there. That's the end of the section. Nothing else to say.